Hi everyone, I am Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic block cipher modes of operation. So first we have to know what is block cipher. So the plain text is divided into number of blocks and each block consists of B bits. It should be of fixed length and this B bit block is encrypted to produce a B bit ciphertext block. So what happens if the plain text length is greater than B bits? So in that case, you have to divide the plain text into B bit blocks, and if you want, you have to add necessary zeros, that is padding is applied, and again you have to apply the encryption algorithm and we have to produce the ciphertext block. So when the plain text is divided into number of blocks, automatically the security issues arise. To overcome this, we have proposed so many modes of operation and we can have different types of messages. So for each type of messages, we can go with a particular mode of operation. So we have totally 5 modes: electronic codebook mode, cipher block chaining mode, cipher feedback mode, output feedback mode, and finally the counter mode. So what is electronic codebook mode? It is the simplest mode of operation. Here the plain text is divided into number of fixed size block, and if the block size is less than a specific size, then you have to add extra zeros, that is the padding is done. Then you have to take one block at a time and that block is encrypted and the ciphertext is produced. And for both the encryption and decryption and for every block we use the same key. That is, this is what happening in electronic codebook mode. The plain text is divided into number of blocks, P1, P2, etc. up to Pn are the plain text blocks, and each block contains fixed length and it is encrypted with the help of the key K, and the ciphertext block is obtained. At the receiver end, the same procedure is applied. That is, every ciphertext block is decrypted using the same key to produce the plain text block. So what is the drawback of this method means it can produce a repeating patterns. So to overcome the security issues of electronic codebook mode, we go with cipher block chaining mode. Why it is called as cipher block chaining modes? Cipher block chaining mode means here the input to the encryption algorithm is the XOR of the current plain text block and the preceding ciphertext block. Okay, that is, you have to apply the XOR of current plain text block and the preceding ciphertext block. That's why it's called a cipher block chaining mode. So repeating patterns are not exposed, and again you can use the same key for both the encryption and decryption. So this is the diagram. So initially the plain text are divided into n number of blocks. Okay, every time the current plain text block is XORed with the previous ciphertext block. Okay, since we don't have any previous ciphertext block for the first block, you have to go with some random initialization vector. First time alone it is used, and for producing the second block and all, you have to chain the previous ciphertext block. So the plain text block is XORed with the previous ciphertext block and the resultant is encrypted using the key. Thus we have produced the second ciphertext block. It is chained to the next stage and so on. So the decryption is the same thing. Ciphertext block, we have the ciphertext block. It is decrypted using the key. Okay, when decrypting, you have to XOR the current plain text and the previous ciphertext. Since we don't have any previous ciphertext for the first block, you have to go with the initialization vector. And for encryption and decryption, we have used the same key. So the advantages of CBC mode is, if the input is greater than B bits, it works well and it is a good authentication mechanisms, and it is highly resistive to cryptanalysis attack. The drawback is parallel encryption is not possible because every block depends on the previous cipher. The next mode is cipher feedback mode. So block cipher as a stream cipher. Here we treat the block cipher as a stream cipher. So that is continuously we are getting the input. Okay. So here you don't need to pad a message, and the plain text is divided into not the blocks, they are divided into segments, and the segment size is S. S can have any value, but commonly we have chosen S is 8. And this is the diagram. So initially we have the initial vector. So it is encrypted using the key. From the output you have to select S bits, and the remaining B minus S bits are discarded. The selected S bits are XORed with the current plain text block. It is not a block, a segment. So the segment size is S. Thus we have produced the ciphertext block. Okay. In the second iteration, that ciphertext block is loaded into shift register. They are shifted. The shifted bits are encrypted using the key. Again, from the output you have to select the S bits. B minus S bits can be discarded. The selected X bits are XORed with the current plain text segment, and the ciphertext block, ciphertext segment C2 is produced. So this is repeated for every segments. And for decryption also the same thing. Initially we have the initialization vector. So see, for decryption also we are using the same cipher encrypt. Okay. So the initialization vector is encrypted using the key. S bits are selected. The selected S bits are XORed with the ciphertext segment, not the plain text segment, ciphertext segment. Okay. So this ciphertext segment is loaded in shift register and it is shifted. Again it is encrypted using the key. S bits are selected, B minus S bits are discarded, and the selected S bits are XORed with the next ciphertext segment, and we have recovered the plain text segment P2. This is repeated for every segment. The next one is output feedback mode. So this is somewhat similar to the previous method. The output of the encryption function, is XORed with the plain text. That's why it's called as output feedback mode. Okay, during the encryption, the output of encryption is XORed with the plain text. And for encryption, okay, we use the previous outputs to chain with the other. And for decryption also, the output of encryption is XORed not with the plain text, it is XORed with the ciphertext. Okay. So this is output feedback mode. Finally, the counter mode. So counter mode, so here we use a counter. So we know that counter is nothing but it is incremented every time. So the counter is encrypted, and the encrypted counter value is XORed with the plain text. Thus we get the ciphertext. Okay. So the same process is repeated for n counters. For decryption also we use the same counter value. Here also we are using the same encrypt function for decryption. So the encrypted key is XORed with the counter to get the plain text. So that's about block cipher modes of operation. With this I am concluding today's topic. Thank you.